We've already looked at the first four powers of I. I to the first is I squared is -1, I to the third is -I, and I to the fourth is 1. This pattern is just going to keep repeating. So if I wanted to look at I to the fifth power, that is really I to the fourth power times I. Well, I to the fourth power is 1, so that's 1 times I. So I to the fifth is really I again. If you continue, you'd look at I to the sixth, which is I to the fourth times I squared. I to the fourth being 1, and I squared being -1. I to the sixth gives you -1. So you can see that that pattern is repeating. We have another I, we have another -1, so I to the seventh, following that pattern, would be equal to -I, and I to the eighth would be 1 again. So we can use that pattern to count around anytime we want a higher power of I. Let's say we wanted I to the 14th power. Well, we can count 14 times around, so we'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and since we end up on I squared, I to the 14th is equal to I squared, which is -1. Now that's all good and fine, except if I ask you for something like I to the 143rd power, that's going to take you a while. So let's look at a different way to do that. If you are familiar with long division, one way that you can figure out the power of I is by looking at the remainder. If I divide 14 from this example by 4, which is the pattern that makes it start repeating, 4 goes into 14 3 times. Subtract the 12, we get a remainder of 2. Notice that that remainder is the same as that power of I. So we can do that same thing with 143. Take 143, divide by 4. 4 goes into 14 3 times. Subtract the 12, we get 2, bring down the 3. 4 goes into 23 5 times, which is 20. Subtract the 20, we get a remainder of 3. So I to the 143rd is the same as I cubed, which happens to be -I. So I to the 143rd is -I. Now this pattern continues to work. Let's look at I to the 100. If you take 100 and divide it by 4, it actually divides evenly. So the remainder is 0. Well, when the remainder is 0, what we're looking at is I to the 0 power. If you remember your rules of exponents from Algebra 1, you might remember that anything to the 0 power is equal to 1, so I to the 100th is actually equal to 1. Now sometimes you'll see things written slightly differently, such as -1 to the 89th power. Excuse me, -I to the 89th power. In this case, what we should do is apply the exponent first, and then this negative out in front is really saying the opposite of. So we're just going to leave it out there. We're going to figure out the remainder when we divide 89 by 4. 4 goes into 8 2 times with nothing left over, so we bring the 9 down. 4 goes into 9 2 times. Subtract the 8, we get a remainder of 1. So we have the negative out in front, and then I to the first power, which we usually will not write that 1, so our answer would be -I. This can also work if you have a coefficient other than just -1 out in front, such as 654,321 I to the 202nd power. We take 202, divide by 4. 4 goes into 20 5 times. Subtract the 20, get nothing, and bring down the 2. So this is actually our remainder of 2. So we can simplify 654,321 I to the 202nd to be 654,321 I squared. And since we know I squared is really negative 1, this is 654,321 times negative 1, or negative 654,321.